I don't wanna be. I do. I'm feeling goofy.
My name is Joshua Granick. Most of you, know me off of the internet or as Sing Majesty. So just want to say hi. It's very nice to be here in person. Very nice to meet many of you, for the first time, for real or ever. So either way, it's been great. So before kind of diving into things a little bit, I wanted to introduce myself a little bit more, just kind of saying where I've come from. And somehow I feel like it's relevant and important, connected to everything else I'm going to be talking about. So currently, you may know, currently I work at BlackBerry. I am the evangelist for the West Coast. So Bay Area, LA, wherever. I help people know BlackBerry's cool and you should develop for BlackBerry and all that stuff. And before I was working at BlackBerry, I was at Palm. And I was on the WebOS team. I was the lead for native support on the PDK, which was the way to do C++ native applications for Palm WebOS. And that was a great experience. Before that, I had my own company. And interspersed in there, I worked for a social games company and moved on from that. But so rewind and rewind and rewind. I don't know, 1995 or something like that. I got started making websites, and websites were cool. So the internet was brand new, and every website out there was ugly, but it didn't matter because it was on the internet and it was cool. And so we had really great cutting-edge technology to make our websites really, really innovative. We had Comic Sans MS so that it would spice things up. Times New Roman was so formal and templatey, but Comic Sans MS was a really casual, warm font, very playful and fun. It was cool. 1995, 1996, Comic Sans was cool. I think Clippy hadn't emerged yet and kind of squashed some of those dreams. But so the way that I got started was, first of all, I used Netscape Composer, which was great. I loved Netscape Communicator, and that was my preferred method of development. And so using Netscape Communicator, I learned how to build websites by taking apart other websites. So I would go to a website and go, hey, that's cool, how did they do that? And then I'd look at their source and I'd cut and paste, and then I'd mess with it until eventually it would work. And so my Josh's Zone website evolved over time, so that it not only had graphics from Photoshop, but it had, it had construction graphics, which was great. I had an animated GIF section, which was also good. I had a MIDI for every page, so you could get the Inspector Gadget theme, the Friends theme, get some Duran Duran or Depeche Mode, and it had frames too, because frames were really innovative. And so the really creative stuff that you would see on the web was someone who used frames that looked like curtains, and you could drag the frames open, and oh my goodness, there's a website in there. This was the stuff that we could do with the web, and it was really, really amazing. But times changed, and I'm very glad the times have changed, and we're going to talk a little bit more about how times changed. But so before talking a little bit more about how times changed with web development and everything else, I want to cover some of the history of Enemy. So Enemy, if you haven't heard about it, it's awesome. It lets you take code and, hey, I want it on my phone, and wow, it is on my phone, and move on with life. So there's, some people might not know the history of Enemy. In fact, I didn't know all the history of Enemy. So that's an interesting clue. So show of hands, does anyone know who created Enemy? Who? Lee McCall Sylvester created Enemy. Sorry, I didn't create it. And Hugh didn't create it either. Rewind to 2007. Lee McCall Sylvester builds Enemy, a new library that exposes STL drawing functions to Nico. So you have Hacks. Hacks is awesome. You want to put it on the desktop, but wait, I want to do more than a console app. How do I do that? So STL is a great way to get things up and running. STL can expose an OpenGL context, which we use today, or it exposes 2D drawing functions, which some people will build a whole game out of that. So Lee got a Tetris clone up and running, and it was kind of like a proof of concept. Like, bam, look, we've got stuff on the desktop, and that's how Enemy started. Now, meanwhile, Hugh Sanderson, so he started a blog called Game Hacks, where he was thinking about, he was a C++ developer building games, and he wanted to build stuff for the web. And so there were different ideas about how that might work, and he was hoping that Hacks would work, because he really, anyway, it seemed like the right choice, and it did work out. He found that the performance was great, and that it did everything he needed it to do, and so he started working on building, being able to use Hacks to do Flash games. Because he had been working with C++ on the desktop, he wanted to be able to do web games as well as downloadable games. So as he was working on web stuff, Lee was working on desktop stuff. And so, I don't know, 6 months or so after Enemy was created, he was satisfied in Flash, it was working, Hacks was working, and so he said, it's time to do the downloadable part. So the first thing that he did is he wanted to have a parallel for the Flash API. Because, as we all know, if you're building something, it's great if you could build it once and have that work instead of building it multiple times. Why would you want to create 2 games when you could just create 1 game and move on with life? So he decided to create a new library called Blink, which he renamed about 3 days later to Niche, as a combination of Nico and Flash to be the Flash compatibility layer that would run on top of Enemy. So he basically kind of took on the development of Enemy. If you go way, way, way back, and if you are on Google Code, they don't have any skip buttons. Actually, GitHub doesn't have skip buttons either, but you can at least see page 1, page 2, so you can guess what the page is. It's like page 150 or something. But Google Code does not. They use the entire hash, and so I have no idea what the oldest hash is. Good luck with that. But you go all the way back, and you'll find that Lee created the library, and then got it up and running, and then about stopped right about there. And Hugh started working on Enemy because as he was developing Niche, I want this feature or improve this feature. He kept investing back into it, and so he basically kind of took over the library. So 2007, 6 years ago, and we move on from there. Next year, Hugh got things working in Linux, and he made the first official releases, or what he called the first official releases of Niche and Enemy. Enemy was on Hackslib already, but it is probably fair to say that this was the first official release. Oh yeah, that's true, because I think Enemy was released on Hackslib, but someone else did it. Kind of like, oh yeah, we'll kind of push that to Hackslib so that other people can try it out. But anyway, so this is kind of where we've come from, and we're going to talk about where we're going. Most importantly, 2008, and this was a great decision. I love this decision. Hugh decided, I love Nico, but it's not the best thing for performance. So what if Hacks could go to C++? And so he created Hacks CPP, which was a modified version of Hacks that had a C++ target. And he created HXCPP as a runtime library to help that happen. And he got that up and running. So it takes time for something to develop to full maturity, but he was already seeing about 4 times, 5 times performance improvements. So awesome. And C++ is obviously kind of one of the, part of the magic sauce that makes Enemy work and everything work today. So 2008. It's great if you love C++. And 2009, Hugh got Mac and iOS support working. The C++ target became official in Hacks 2.04. So awesome. And Enemy and Niche both got to version 1.0. And it's about this time, what is happening? It's about this time that Hacks C++, Enemy, and Niche started gaining visibility. And so I got started as a web developer. I had various different positions. I got to work at Upper Deck and create stuff for Sidney Crosby of the Pittsburgh Penguins, and create a lot of cool Flash stuff and work for different agencies and work for different things. And by the time I got to having my own company and doing my own production work, I developed up to a point where I could develop games in, you know, say five hours or so. One of my favorite clients that I got to work for, they needed a series of children's games. You know what? Actually, I think this is better if I take this and I put it in a different part of the presentation. So we'll pin this, and we'll move on to the next thing. So let's get our heads back into MIDIs and frames. Browsers are cool, right? MIDIs and frames. But the rise of Flash. So today, it's easy for people to think, oh yeah, Flash, you know, oh, I hate Flash. You know, I hate advertisements. As if, you know, okay, if there wasn't Flash, as if we wouldn't have advertisements in HTML5. You know, as if we wouldn't be using Canvas or something else to do the same thing, because they want to advertise to you and they want it to be animated and dynamic and everything else, you know, whatever. But you go back to the, you know, the good old days of Netscape and IE, and Flash started when Macromedia acquired FutureWave Software. They rebranded FutureSplash as Flash 1.0. 1997, Flash 2 came out. 1998, Flash 3 came out. I didn't put anything next to those because nobody cares. But Flash 4 is when things started to become more interesting. So yes, you had an ability to do some scripting. You could say go to and frame, stop or play. But actions is when things started becoming more interesting. Because, you know, what fun is Flash if you can't really program it at all? You know, so Flash originally starts as an animator, create animation, share it on the web. But when you add the ability to start scripting it, things change and it becomes more interesting. And not only scripting, Flash 4 is also when movie clips came out. And you know, what's more Flash than a movie clip? So Flash 4 came out, and Flash Player reached an installed base of 100 million users. And I hope that's right. I found that on the internet, and I hope their numbers are right. But it's very interesting. And by 2000, Flash 5 was released, officially turning actions into Actionscript, evolving it more. And Flash Player reaches 92% of internet users, again, according to the internet, and hopefully the internet is right. But so by the year 2000, everyone is using Flash. And why was Flash interesting? Why was Flash valuable? So here I was. I've got my MIDIs. I've got my frames. You know, I'm cool. You know, things are cool. And then all of a sudden I go to a site and it's like, whoa, what is that? It was like Flash was the first thing, and I don't know if any of you had the same feeling. It was the first time that I hit a website and it was like, what is that? Oh, like, how did they do that? And then I look at the source code and it's like, I don't understand. Like, what is this thing? And then go and check it out and like, oh wow, you know, and downloaded Macromedia Flash 4, and I didn't understand what was going on, but they had a couple samples, and so once got the idea of how the timeline and tweens worked, was able to build up from there, and then the rest is history. No, so take Flash, and then I started integrating it into my work. So maybe I went a little bit overboard. It was actually probably the thing that taught me that I do like programming, and programming is not evil, because I decided I'm going to make whole web pages in Flash. You know, forget you know this crude HTML stuff. I'm going to do like a really cool Flash site, and it's going to be great, and I'm going to do it all in timeline. And the first time I had an experience making a website where everything was on the timeline, think about this. You have, you know, 8 sections, and animating in and out of every section is on the timeline. So I have a timeline of, you know, I was going like 12 frames per second, so 300 frames was a lot of frames, and I had animations in and out of every single section, and it would jump to the right place on the playhead to play that animation. And so then I wanted to like bump a logo. I had to like bump it in like 40 different keyframes, and then I want to like move the menu a little bit. I have to like move 100 different keyframes, and then so when I discovered Actionscript, it was kind of like, wait, you mean I could just like make that go away, make that appear? Like, you know, it's kind of like mind blowing, and especially by the time I got Tweener and other things like that, libraries like that, is like mind blowing. So Flash is cool. Flash enabled us to do a lot of stuff on the web that we couldn't do. Browsers couldn't do it. Browsers were not cool, but Flash could. The other thing about Flash, and this is something else that I think people forget, you know, who had plugins installed in their browser? Okay, hoping people had plugins, because otherwise I'd feel weird. Who had more than one plugin? Who had more than 2 plugins? Who had 3 or 4 plugins? Well, I guess I said more than 2, so you'd all have 3 at least. Flash, in my opinion, and maybe afterwards someone can give me some harsh words, Flash is the plugin that killed all other plugins, basically. So, I mean, we had Real Player and Windows Media Player and QuickTime, but in essence, especially by the time Flash got video support, Flash is the plugin that killed web plugins. Because why? If you have a plugin that reaches 92% of browsers, why in the world are you going to put a barrier of entry and force them to install a new plugin when you already know they're going to have Flash in their browser? And Flash was in their browser because Flash did cool stuff. It wasn't in their browser because, oh, it's adware. I got an AOL CD, and that's why I've got Flash on my system. Like, Flash was there because Flash did things that the browser could not do. But it did the things we wanted to do with the browser. We wanted to create content and share it with people and have it be dynamic and be able to play sound, play video, and create something interesting and unique, to have like an alpha fade. Just give me an alpha fade. And we could do that with Flash. You try and do that with CSS, or back when they called it DHTML, it was not cool. And it didn't work very well, and yeah, God help you. So Flash is cool. And it let us do things like, I'm going to play. Play. It's a different version of PowerPoint. It's not playing. It's not playing. Do we have internet on here? I don't know if I should conserve her or ignore her.
I would conserve it.
Yeah, ignore it, right? Yeah. Okay. I'm sorry, but I think, it's a video? Or what? You have it on your
It was a video.
Chrome?
Okay.
Okay.
What? That's not right.
The French keyboard.
Oh, nice.
ZT.
Do I have to shift to get it? You have to shift to get numbers. That's weird. A shift to get a period. Oh, jeez. This is the browser worse.
Someone set up the bar. We get signal. Locked. Main screen turn on. Are you gentlemen? All your data belong to us. You are on the way for destruction. What do you say? You have no chance to survive Major time.
He's waiting for Flash to come, So don't have enough time to play the entire thing, but all your base belong to us. So Flash is awesome, and if you're another plugin, watch out, because all your browser belong to us. And what comes next? Right, what happened? Somebody set us up the bomb, right? No, so what happened? So, we've got the heyday of Flash, and Flash is out, and Flash is great, but something changed. There was a pivot. So I think if you take content, you have creative content, you have creative people, you want to get your content out there. For 1999, 2000, a plugin was perfect. A plugin was exactly the way to get in a browser, to have a consistent experience. But something changed. The industry changed. So the first thing that changed is the team changed. Adobe acquired Macromedia. So regardless of your opinions, it doesn't matter. It's all in the past anyway. It doesn't matter. It just changed things. So for better or for worse, I think some of both, things changed. So that's one thing that changed Flash. The next thing that changed Flash, or at least changed maybe what we needed, the right solution. The next thing that changed is the mobile industry exploded. So running things on a desktop is totally different than mobile. And we'll talk about that in a little bit, but mobile changed things. And did Flash, pivot and adjust for that new paradigm. And the next thing that changed is the browsers got better. People say, oh, the browser's the future, and the browser's great, and we can do everything in the browser. We didn't used to be able to do that in the browser. The browser used to stink. So like, it's cool, you know, it's great that the browser's gotten better, and so some of our, you know, the way that things have to work should pivot on taking advantages of the strengths of the way the browsers have changed. But, you know, when people say, oh, Flash is lame, and you know, we never liked Flash, it's like, really? You know, and you forget that Flash has been doing what the browser should have been doing, or what we wanted the browser to be doing this whole time. And again, Flash 4 came out in 1999. And how long ago was that? 14 years. 14 years later, yeah, I could probably do the same stuff in the browser that I could do in Flash 4, Flash 5. Like, things are catching up, but it's not instant and it's not overnight. But we should still take advantage of what's there. So the game has changed. So the future is mobile. There are many countries where people have mobile phones. They do not have a laptop. They do not have a desktop. They have a phone. Their phone is their first computing device. They get a BlackBerry, they get a whatever, and their phone is their connection to the world. I believe that, you know, obviously it depends on what you're doing, but still I think a lot of content, a lot of the ways that we connect with, you know, connect with people, connect with email, connect with Twitter, Facebook, whatever, it starts with our phones. So I think any strategy for, you know, if we were to imagine a Flash today or anything today, it's important that mobile is, in my opinion, that mobile is taken care of first. Because mobile is, if you can't do mobile, then, you know, being on the desktop nowadays is not really ideal. But if you can do mobile, sure, of course you can do desktop, depending on the technology you use. But we're at a hacks conference, so of course you can do the desktop. So getting good results on mobile devices, though, requires utilization of the hardware. And this is a significant shift from the technology to run on a desktop. Even today, running in software might be the best way to be on the desktop. Because you have people with like really great, you know, awesome, I've got a, you know, super GPU that could power, you know, space astronauts or whatever else, like it can do anything, but then you have the next guy who's like, oh, I've got an Intel integrated GPU and it's awful and, you know, whatever. Like, in order to get consistency, and also because the CPU is very, 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 very fast on a desktop, running in software like Flash does is good for the desktop. But when you're on mobile, it's a low power device, and your performance, quite honestly, is terrible unless you can run on the hardware. So not only do you want to run as close to the metal as possible by being native instead of running in a scripting language or something, you know, God bless HTML5, but native runs so much faster on mobile, so much faster. And rendering performance especially. You need to access the GPU. If you're not accessing the GPU on mobile, again, it's a sad thing. The other thing about mobile is that the industry is constantly shifting, so it's important to be, in my opinion, to be agile. So, you know, one day this platform is the coolest platform in the world, the next moment all of a sudden it's gone, and you have another platform, things are changing. Just this year, you know, we have Firefox OS and Ubuntu Mobile and Tizen, and I don't know what's going to happen with them. Maybe they'll be cool, maybe people will like it, maybe they won't. I don't know. But things change in the mobile industry. It's not the same as the PC desktop industry where it's more established. Things are shifting. And so if I'm going to pick a technology that's going to let me do what I want to do for the next 5 to 10 years, I need to pick something that I believe is going to be able to pivot or that I believe is flexible enough to be able to kind of reach in, change it, adjust it, and change with the times and move with the times. And that last bullet point is kind of redundant. Yeah, constantly changing in terms of relevance. So browsers get SMRT. They started getting smarter. So I would say that plugins are now unnecessary for most common tasks. So most of our backlash against having a Flash plugin is really about having a plugin at all. You know, well, a plugin, or, you know, someone could argue that the Apple engineers maybe could do something better. But I don't know why that laptop like turns into the surface of the sun when you open Flash Player, but it does, and it's just not right. Something about that is not right. But wait, why is that doing that? I don't want to, okay. So plugins are necessary for most things. So if you want to do a slideshow, it used to be that Flash was the best way to do that. Today, you know, use the DOM for that. Use the browser for that. Cool. If you want to do an interactive, you know, like, you know, I see all the stuff that Philippe comes up for Mercedes or whatever else. It's like, it's all in JavaScript. It's all in the browser. Cool. It's good at that. There are still things that I believe the Flash plugin is still good for, but for all the things that the Flash plugin is not necessary for, maybe it's fine. Use the browser for that. That's good. Particularly on mobile, and this has pretty much gone away. Plugins are particularly problematic on mobile. It just doesn't work well there. Again, CPU is limited, memory is limited. Plugins don't necessarily tap into the hardware like they need to. It's just plugins. It's like mobile browsers have a hard enough time of it already. Let's not burden them with plugins. So again, plugins was a good paradigm for the 90s, but browsers have finally started to grow up. They're toddling around. So you need to be careful. Don't give it scissors. But otherwise, there's a lot of things that the browser can do. Also, WebGL is gaining traction and offers the best rendering performance in a web browser. So before we had Canvas and before we accelerated Canvas, trying to do a game in a browser, you could do it with DOM elements, but it's very, very crude. Canvas made things a lot better, but it's still it's still CPU bound. Even if you accelerate it, it's still a pixel-based API. So you take systems like Windows 8, Internet Explorer 10 gets probably the fastest Canvas performance I've seen in any browser. Surprise, Internet Explorer is running fast. But you take something that runs about this big, it's running fast, and you try and scale it up to a 1920 by 1280 desktop monitor or something like that. All of a sudden, oh no, we're using a pixel-based API, and it doesn't work very well. So WebGL allows us an ability to move beyond pixels to accessing the GPU more directly, to kind of punch a hole through the browser, touch the graphics card, and so if someone has a ghetto Intel GPU, it might still be limited, but to anyone else, you have an ability to actually get quite possibly better performance because you're able to more directly access the hardware. So WebGL is great. It's available in Firefox and Chrome by default. You can enable it in Opera and Safari. The only thing that's missing there on the desktop is Internet Explorer, and there was a leak, or supposed leak, that Internet Explorer 11 this fall is going to have WebGL. And then a couple weeks ago, I guess it was like a Vine video where Microsoft was kind of like, wink, wink, what's next? WebGL, wink. Kind of like, yeah, maybe we're going to do that. So that would take care of the desktop. Now on mobile, BlackBerry 10 has WebGL. Android has started to get WebGL through Firefox, through Opera, through the Chrome beta, and some stock browsers. So it's pretty much there for Android. So really what's missing on mobile then is iOS, which actually has had it this whole time for advertisers. So, yay, so we can have a Flash replacement, and we'll have WebGL instead of Flash, and we can do our advertisements. But bottom line there is that they do have the technology. They haven't been opening it up to developers, but that could change. So WebGL, if WebGL is available across browsers, that changes things. That changes what we can accomplish in the browser. And lastly, browser compatibility is still an issue, particularly when trying to reach 98% of existing users. If you want to create a website that can reach most everyone, and it's not a niche, it's not just for gamers or something like that, you still can't use something like WebGL. So Canvas, or maybe not even using Canvas, may make sense. But I would still argue that if you're creating something like a game, Canvas is still something that you can reasonably target to reach web users. You could probably move beyond just DOM APIs for that. But anyway, so we'll keep on moving on because I know we want to get to the good stuff. So Actionscript. So why not Actionscript? Well, we're at a Hacks conference, so I shouldn't be up here telling you to use Actionscript. But here's a couple choice quotes from the 2012 Flash Player Roadmap. So what does Adobe think about Actionscript? In 2012, quote, "The range of applications and content for Actionscript has shifted significantly in recent years, while the Actionscript 3 language remains virtually unchanged since its introduction in 2006. Adobe believes it is time to revise the language to carefully steer its further evolution towards greater expressiveness, as well as productivity and performance gains. Actionscript 3 tends to lapse into dynamic typing all too easily in places where absolutely stringent static typing would be preferable, and Adobe aims to simplify the language." So I'm not going to go deeply into it, but I would argue if you love Actionscript 3, and I loved Actionscript 3, Actionscript 1 was a pain. ActionScript 1, it would work, and then you like messed up a comma or something, and your entire thing explodes, and you don't know why, and you try and figure that out. But ActionScript 3, when I got ActionScript 3 and Flash Develop, that's when I really started loving development. So I still believe there are people out there who love ActionScript, who like ActionScript 3, and I see new projects coming out that are targeting ActionScript 3. But if you look at something like this, given since 2006 to today, so you have 7 years of ActionScript 3, and yeah, that's the right math. You have 7 years of ActionScript 3, and Adobe believes that ActionScript that they could do better, that there could be better than ActionScript 3. Not that ActionScript 3 is inherently awful, but things have changed. But ActionScript 3 has not changed. And the ideal would be to carefully steer all the great things about ActionScript 3, make it more expressive, to be more productive, to have improvements in performance, to make it, they wanted to add static typing so that you could get better performance. They wanted to add type inference, so you didn't have to type types all the time. So you can get the balance of jamming on some code real fast, like JavaScript, but getting the static typing of a stricter language, but also to simplify some things. And I would argue that this is hacks. So if you want ActionScript 3, but you want to move it in this direction, in the direction of ActionScript Next that never happened, that's hacks. Hacks has static typing. Hacks has type inference. Hacks is, in certain ways, a simplified version of ActionScript 3. But Hacks is most definitely more expressive, more productive, and more performant, in my opinion, than ActionScript. So for the future, especially for looking towards the future, what do we use for 5 to 10 years? I believe that Hacks is the right language for that. ActionScript is not the right language. But if you love ActionScript, you will adore Hacks. So do it. Hacks is my hero. But I want to just say, so Hacks, like Nicholas talked about yesterday, Hacks is a toolkit to build cross-platform frameworks, to build cross-platform applications. Hacks is a toolkit that enables you to do lots of things. But if you're looking at it particularly through a Flash lens, 2003 Flash 7 is released, adding ActionScript 2 support, and in 2004 MTask is created. It's the first open source ActionScript 2 compiler. It's the only open source ActionScript compiler I know of. That's not a very big time gap there. 2005, the Flash 8.5 alpha is released, and Hacks is introduced the same year. And in 2006, Hacks is released before Flash 9 is released. And in the same year, Hacks added JavaScript support. So from day one of Flash Player 9, we've had 2 languages that target Flash, Hacks and ActionScript. So people can say, but ActionScript is classic. It's the way we've always targeted Flash. Hacks is the way we've always targeted Flash too. So if you're a Flash developer and you want to move forward with that, Hacks has been there. And not only has Hacks been there, Hacks has supported features before or in parity with Flash Player. So, flash memory that they finally exposed, Hacks has been using that for a very long time. So, if you consider yourself like a true blue, like I am like a Flash developer, that's who I am. It's like Hacks is there with you. And here's the rest of the history. In 2007, Hacks got better. In 2008, it got even better. In 2009, it kept improving, got C++ and better. In 2010, it's still better. In 2011, it got even stronger and better. In 2012, it got C# and Java, and oh yeah, it got better. In 2013, we've got Hacks 3. It's even better. And I think in 2014, it's elected president or something like that. And this is the news. So what we're announcing today, what's new, what's going on? So NME. So you go back to the history of NME. What was going on there? NME was a native backend. And on top of NME as a native backend was Niche, a library created to provide Flash functionality. When Hugh re-engineered NME for NME 2.0, which is about the time that I joined the project, started working with it, added WebOS and whatever, that's not important. When he re-engineered it, for performance reasons, a lot of that Hacks code moved into C++ to get it a little bit closer to the rendering engine and stuff like that. And that's when the Niche library kind of went away. And I took NME, and I thought, I like NME as a name a lot better than Niche. And NME had a cool logo already. So took NME, and it's like, we need a single API that we can take and we can target. So we can have one API, and we can target that API, but we can go across mobile and desktop and web, and we can use that. But as we've been working through, so there's a lot of things that people have said about, everyone has an opinion about what we can do to make Enemy better, to make it, target the future and everything else. And so, the direction we really want to take this is creating a new library called OpenFL. So the first thing is, hopefully, OpenFL, when you hear it, you're not wondering, what is that? And what's that spelled? And is that a magazine in the UK? And if you search that on Twitter, you won't, you'll actually be able to find something related to it. This is taking everything that we've done before and perfecting it. Enemy has always been a Flash similar API. Well, taking that technology and saying, this is the Flash API. Now, not following it like lemmings off a cliff, not taking the things that are, awful, arguably awful and saying, okay, us too, and kind of leaping over the edge. But if you are a Flash developer, if you enjoy the Flash API, Flash is an industry standard 2D API. We can implement it and we can fulfill the vision to take a Flash API content. It's not about the plugin. It's not about the runtime. It's about the API. It's about being able to write your code and to be able to target everything you want to target. And so we can take that and we can deliver something that's the environment that you expect, where stage is not null when you create your project, where you can use the file tag or the bitmap tag or the sound tag like in Hack's Flash, but use that across JavaScript, use that across C++. We can provide a Hack's Flash kind of development environment for you. And that's just the beginning. Obviously, there are new ideas for APIs that we could use for development, and we can continue to innovate on that. And I hope that OpenFL can provide a foundation for innovating on those technologies, but also create choices. So we can take the Flash API, do that really, really well, and then be able to head off in other directions as we see fit. So it's an open source Flash library. It is free and open source. It is available today as a release candidate for Windows, Mac, and Linux. Developing from Windows, Mac, or Linux. It has built-in support for mobile, desktop, and web. You can target using native C++ and OpenGL, Flash, JavaScript. It also has beta support for Mscripton if you want to do WebGL. It includes support for over 800 Flash APIs across platforms. It provides a robust low-level API based on WebGL for all targets. So even if you don't like the Flash API, but we all know that WebGL is coming to browsers and everything else. If WebGL is similar to OpenGL and OpenGLES, and that's intentional, but we have an environment where you can use an OpenGL view. You're writing against the WebGL API. It will run in HTML5. It will run on the browser, it will run on the desktop, and it will run on mobile. So you can have a single accelerated API. If you think, I don't like the Flash API, I don't like the display list, don't use it. You don't need it. Or if you want it, you go ahead and use it for, I don't know. Anyway, you can mix and match. But if you just want a 3D accelerated, just kind of a footing, I just want a platform where I can just, accelerate some stuff. And maybe you're a framework developer and you've got great ideas about something better than the Flash API. This might be a great way to get started with that. And we can continue to innovate and continue to move forward with how we can use the Hacks toolkit to build the best cross-platform tools, not just for Flash developers or for the Flash API, but for other APIs and other perspectives on cross-platform development as well. It's backed by the Hacks Foundation and backed by a vibrant, passionate developer community. That's us. OpenFL, I believe, is agile and ready for the future. It's been re-architected to make it even easier and more flexible to target current platforms. So well, I'll explain that in a minute. It's the Flash API with or without the Flash runtime. You can effectively target native and web platforms from the same unified source code. It is re-engineered to maximize Hacks 3 improvements. So it is not Hacks 2 compatible. It is Hacks 3 only. But that is specifically something that enables some of the improvements that have happened over NME. It improves quality of life when migrating old Flash projects, and it is fully compatible with existing NME projects. So if you have a project and it says, I want NME, OpenFL will automatically load up a compatibility library that creates the mappings necessary to build that project. As far as development goes, the big shift is kind of targeted more at kind of the Flash style of things. So you still have, as a distinction, you still have things like Tilesheet from NME. You still have things like the assets class, but that's in an OpenFL package. If something is Flash, it's in the Flash package. If something is not Flash, it's in the OpenFL package. So there's always a clear distinction between this is the Flash API and this is something that's been added as a convenience to you. And you have an option of which to use. And so the encouragement would be kind of the direction for how OpenFL development would look different than NME development. If you're already an NME developer and know what that looks like. The standard project file extension might be more like Project XML instead of Project NMML. Though either would work. Instead of using NME display sprite, you probably would use Flash display sprite. And so in essence, the direction would be that if you take a Hacks Flash project that never worked on NME, one of the big focuses of this project has been for those projects to work. You take a game like Nicholas's Evoland game that he created, not the new one. He hasn't given me that source code. But the one that he created for Ludum Dare or Dare, depending on who you are and how you like to pronunciate things. You take a game like that, it didn't run in NME. And why? We don't implement color matrix filter, and it's like that's got to change. So Evoland, it runs in HTML5, it runs in native, it runs on the desktop, it runs it could run in WebGL. That's another thing. Mscripten is still a beta target. Development on Mscripten itself is continuing, just as our support for Mscripten does. So in the file APIs, for example, if you use OpenFL assets, that works on Mscripten. But if you have embedded assets, Mscripten doesn't have a way of actually taking bytes from memory and using that as an asset, but that will be fixed. So so this is where we're at. If you go on HacksLib, you can install OpenFL. It is available, and it is great. Still have some time, so if anyone has any questions, anything I didn't cover, any confusion, let me help.
That's good. If you say it's covering Flash more than NME does, would it allow you to actually compile Flex, for instance?
That could be done. Obviously, Flex would have to be ported. So architecturally, I know some of you may be interested in kind of, how does the library look different, or how has it been re-engineered? One of the big shifts that's happened with OpenFL over NME is that it is not one library. OpenFL is a suite of libraries. In essence, what that allows us to do, if you're interested in improving some part of it, or you like most of it, but you're not quite sure about another part of it, it's flexible. So you can take OpenFL, and you can have OpenFL native and OpenFL HTML5, but you say, I want a different HTML5 target. You could use HacksLib dev, swap out the OpenFL HTML library with your own copy, working in a completely different format and completely different way, implemented against the same API. As a developer, this should also make things a lot clearer. So there's no more browser and native and everything else. Inside OpenFL HTML5, there's only a few directories. There's a Flash directory for all the Flash classes, and there's an OpenFL directory for the OpenFL classes, and there's a templates directory for the index HTML and stuff like that. And that's the way that it's been created across the board. The next thing that's being done against OpenFL that was missing in NME is a unit testing. So currently OpenFL is being unit tested using munit. It's being run in HTML5 and C++ and Nico and Flash, testing against the API. So currently, of the 800 to 900 APIs that are supported, we have tests for about 10%. Working on writing more tests, but we've been continued to improve the library as we go, as tests reveal little minor differences between them, so that we can ensure consistency. So if you wanted to port something like Flex, there obviously would be a shift from Actionscript to Hacks, but we're continuing to move more and more in stability and consistency in our support of the Flash API. So that portion of porting something like Flex should be shifted. And then the other part about porting something like Flex or an application framework is if there are particular ways that the existing HTML5 target or something like that doesn't perfectly suit the runtime needs of that library, we now have flexibility to reinvent or reimagine what some of these things may look like. And to be able to swap these out so you could hack on HTML5 without having to rebuild binaries, without having to have unstable tools or something like that. You can have the same tools, same native target, but then we can swap it HTML5. You know, what would it look like if it was a DOM-based HTML5 instead of Canvas? Or what would it look like if, you know, we can do those types of things. So I'm hoping, you know, to people who are interested in building applications, this opens things up so that we can take it and use it at how we need it. It also makes the tools separate from OpenFL as well. So in theory, the tools could be used for more libraries than just OpenFL. It's currently set up right now where if you included OpenFL tools as a lib, all of the source code for the tools is available. So in theory, it could act as a base class for other tools, which you use it as a backend, or it could be white labeled, where currently when OpenFL runs the tools, OpenFL tells the tools, this is OpenFL wanting to run the tools. And that's what helps brand it as OpenFL tools. So there's ways that we could leverage the same backbone of take a project file and build it, target, get it on a device, but we could potentially open that up for other HACS libraries that need that support, that tooling support to accomplish what they need to do, and white label it so that it's, you know, clearly, you know, the right tools and adjusted for that platform and otherwise.
Should we for the package, should we be using OpenFL rather than Flash for the package?
So currently for anything in the Flash API, the package is Flash. So it's one of the things I didn't know there was a little trick to be able to use the Flash package when you're not targeting Flash in HACS. And with HACS 3, there are improvements so that trick isn't necessary anymore. So we can go. We are using, and actually, if you go back to what Hugh originally intended before he created Blink, he specifically said he wanted to create a package called Flash, and there were reasons why he couldn't do that, and that's when he thought of Blink, and then decided to call it Niche instead. So we're kind of going back to that original vision of we are implementing the Flash classes for native for HTML5, so that's all it's called. Yeah, it's Flash Sprite, but the OpenFL package is used if it's something added. So OpenFL display FPS or OpenFL display OpenGL view, things like that.
Hi, so what's the relation now between OpenFL and Enemy? Is OpenFL replacing Enemy, or is Enemy now using OpenFL underneath? So, so what I would say is that if you are, you know, if you're using Enemy as a developer, I think that OpenFL is probably what you want to be using. Enemy, but in the adjustment in this relationship, you know, Enemy used to be a native backend only, and Niche provided the HACS level classes to use a Flash API over the top of it. What I imagine, and continuing to work with Hugh and other people on kind of the direction of things, what I see happening is Enemy becoming more of a backend library like it was before. So Enemy is a library that provides native support for rendering and other, you know, platform-specific native functionality for HACS projects. So OpenFL uses the Enemy NDLLs. So the source code for the, you know, the STL rendering and other things like that is still inside of Enemy. And so OpenFL implements the API over the top of it, but I could expect seeing those kind of low-level API endpoints inside of Enemy remaining stable. And that actually opens things up for potential innovation as well, where if you take the Enemy of yesterday and you wipe away all of the HACS code, and all you have left is the native code plus these endpoints, are there other APIs or other ideas that could come out of, you know, how could we mix and match these rendering endpoints and otherwise with a new API or a new whatever? But it still may be nicer to just, you know, build on top of OpenFL so that you can just say, you know, a sprite works like a sprite and kind of move on from there. Yeah, so if I understand correctly, if you, for your end product, you use OpenFL, and OpenFL currently uses Enemy for certain targets underneath.
Yes. Yeah. Yes. So Enemy, if you're going to hack on the like the OpenFL native library, so that's everything that gets loaded up when you target a C++ target or a Nico target. The NDL you could load it up with NDLLs from a stable version of OpenFL, and you don't have to recompile anything. You could hack on the HACS code. If you wanted to update the native code,
then you would still be checking out enemy and working with enemy for that. But for all the rest of it and any other part of the project, you wouldn't actually be working with enemy for that. And so it's just more of a implementation detail if you're developing, helping improve the library. But for a user, you install OpenFL libraries and they're done.
Okay, thank you.
Do you plan to support media APIs like video, microphone, camera?
That's something that I would definitely like to see. So the first focus for this release was obviously setting up the right architecture, taking all of the input that we had and ways that we could improve on how enemy was doing things before and how we could do things better. And I feel that that's been successful. And the second step is expanding on our unit tests to make sure and validate that everything that we do support now is very stable. Any kind of skunk works to in development type APIs, not exposing that in the same way as previously. It would be like, hey, we're working on something new and cool, and check it out. Well, okay, wait, it runs on my machine. Maybe it won't run on your machine yet, but it'll be cool. Instead, we're going to wait on that stuff, and we're going to make sure that things stabilize, and this is a mature, stable platform that people can rely on. So we want to make sure everything that's there is reliable. And then the next thing I'd like to see is adding things like that where there's no reason why we couldn't have microphone access, and that's something that I'd really love to see. So we'll finish out validating what we have now, and then we'll write some tests for microphone access, and then see if we can get that implemented for more platforms.
There's a question on Twitter from Sunjammer. How do you target Stage 3D for Flash using the WebGL API?
Okay, so WebGL, Stage 3D, Flash. All right. So there's been a lot of kind of how do we solve this 3D acceleration on all platforms, including the Flash runtime problem. It's gone multiple different ways. Should it be Stage 3 and should it be? And what I've usually heard back, and again, feel free to tweet me or talk to me if you have a different feeling about this. But when I ask people, would you rather be doing OpenGL or would you rather be doing Stage 3D? Almost always the answer I get is I'd rather be doing OpenGL. Doing OpenGL, that's a skill that is transferable. That's a skill that's good for the future. Doing Stage 3D is potentially not the best investment for the future in terms of skills and otherwise. So that's the first part of it. And the second part of it, obviously, when you get into shaders, would you rather write AGAL or would you rather write GLSL? It's like, people shake their heads when they hear AGAL. It's like, no, please, So I feel like that's what people want to be writing. Second thing, like I said earlier, want to be sure that we're promoting things that are stable. And so right now, what's stable for native and for HTML5 is OpenGL View. That's something also that's changed over enemy. OpenGL View is available for mobile. It's available for iOS, Android, and BlackBerry. So OpenGL View is a stable way to have hardware acceleration on every platform except for the Flash runtime. If you still need the Flash runtime today, I think that perhaps the best solution is actually to do Stage 3D and OpenGL separately. Or one other idea would be to do something, there's at least two different ideas, and I think that this is something that, as a community, we can develop these tools if we need them. One idea is to do to go the direction of Stage 3D compatibility. So you use Stage 3D on Flash, and we implement Stage 3D compatibility on top of OpenGL View. I've done numerous small projects that did that successfully, using some of the code that's out there today and improving on that code. So we could head in that direction. But again, the feedback I usually get from people is that they don't want to be writing against Stage 3D. They want to be writing against OpenGL instead. And so another possible direction is taking Adobe's, I believe it's called GLS 3D project, where they have a project for doing OpenGL on the top of Stage 3D. And maybe the best way is to go the opposite direction. So you use an OpenGL view, and together we implement an OpenGL view for Stage 3D. So you use a WebGL API, and then have that work on top of Stage 3D, so that way we can, we can kind of plan for the future, work towards the future, while still being able to target the Flash runtime, as it's available. So there are multiple potential solutions to that, But I think, you know, at the very least for today, the right thing is to stick with what's stable. And what's stable right now is, you know, Stage 3D is obviously the only 3D acceleration path in the Flash runtime, and then we can offer the OpenGL view as a stable path for every other target.
Another question from Twitter from Mohamed Shaban. Does OpenFL use the same libraries as AxeNME?
It should. So obviously there might be some minor changes. If you have a library that is loading up, you know, is referencing enemy display sprite, that will only work if you include the OpenFL compatibility library, so that it can create the mapping from enemy back to OpenFL. With that library, it should work fine. I would expect to see libraries making it should be minor adjustments to move from enemy to OpenFL. Mostly just, you know, the package name changes, and then they should be able to work. Biggest shift probably is just HAX 3, and all things considered, HAX 3 is not that big of a shift, in my opinion, and I like HAX 3 a lot better than HAX 2 personally. I like HAX 2, but I like HAX 3 even better. Like I said, it gets better, 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 better. HAX is getting better. So that's probably, if there's any changes that you would have, taking an existing enemy compatible library, it would be moving to HAX 3. Any other questions?
Thank you. Is a long-term goal for OpenFL to be able to support 100% of the Flash API, like sockets, application domain, loaders, and other Flash-specific stuffs?
So I would say it's difficult to find where exactly the line should be, and you know, I can't think of any one thing to point to that says this is the line that says everything over here we support, everything here we don't. Everything we do support, we're going to be publishing what's supported down to specific methods and properties and down to specific platforms. One of the benefits of unit testing, it's going to give us an ability to have further clarity on what's available, so we'll be able to publish exactly what you can count on to be there in each platform. I would expect most of the, you know, what one might consider core Flash API, you take something like bitmap data and it's like, yeah, I need that. You take something like accessibility properties and you think, well, maybe I don't really need that. So, so I would say that we plan on supporting the stuff that people tend to need. OpenFL currently does have application domain for like code compatibility's sake. So that's definitely a big goal in terms of being able to compile existing code and have it work as you would expect. But there are certain paradigms like you know, the application domain loading classes out of the application domain versus, you know, whereas when you go to C++, everything got compiled together, and that doesn't really make as much sense anymore. So there are some adjustments based on the platforms, but I think that's okay. You know, we all know that HTML5 is not 100% the same as native. You can't, you know, execute a process when you're in the browser. You know, we all understand that. So we're not going to hide those differences. And we're going to, the number one goal is to be able to take Flash compatible code and to compile that for new platforms. So, you know, so certain features may not be implemented yet. Other features may not make any sense at all. But in any ways that we can, if it's something that non-essential, like, you know, referencing an application domain while using a loader or something like that, we want to at least implement out something that's going to compile properly and that will still work, even if some of the smallest nuances of it are still different.
A lot of people are asking about the website. Where's the website?
So the
openfl.org is a white blank page, and
yes, openfl.org is a white blank page, but that is the site. So I hope you love it. It's yeah, it's taken great investment. We got a pro designer to work on it, so no, actually working with the designer right now on a new site. Hope to be launching something at least simple soon. Got into more of a code crunch on getting the code ready than the website right before getting here. But yeah, we'll be posting more there. So for now, obviously the forums and everything else, you know, you can still use NME if you have questions. You can use those forums and everything else, but we're going to be, you know, building out a new site there.
Question on, are you thinking that Java and .NET?
Yeah.
So it's off.
On the top.
My question is, are you expecting the Java and .NET Haxi targets to be supported in the future?
So, I was talking to Ka about one of the things that he'd like to see, and that I think should definitely be possible, is there's potentially some interest for having so Niche was like a completely Hax-based Flash implementation. And then its hooks into Enemy was fairly minimal until Enemy 2, when things got refactored and Enemy got more awesome. But I think that there's still room for creating a new back end like that. We currently have the back end that's relatively lightweight that hooks into the native code. We have a back end that's designed for HTML5 that's all implemented in Hax. And I think there's room potentially for a third back end that is, and possibly this might be kind of emerging with the HTML5 target, kind of moving in this direction, is making more of a generic Flash implementation, a generic back end that's all written in Flash, and then HTML5 might be one render target. And then we could also, creating something so that if you wanted to work on top of .NET, you could compile it all to C#, and then you just need some little hooks into your rendering endpoints to draw a rectangle or to display a bitmap or something like that. But then all the rest of it would be all implemented in Flash code. And that won't perform as well as the C++ native target, but sometimes in certain environments that might be the only way or the best way to do it. And so scenarios like like running on the PlayStation Vita, where as you hopefully know, may not know, Enemy currently is being used on the PlayStation Vita. Grapefruit, anyway, I'm forgetting all the names I'm supposed to remember, but it's running. It took the Enemy code, compiled it to C#, and implemented a little bit of the display list and other things that he needed, and it's running on the PlayStation Vita. And so I think that there's things that we could do to definitely help support those types of workflows. And again, with the what I'm hoping with the flexibility of the OpenFL libraries, it'll make it easier for us to plug in new backends and create new backends as needed.
Just some question from Twitter. Is there going to be Enemy 3.6?
So Enemy 3.46, I believe, or 3.56 is available on Haxlib now for Hax3 developers to help make that shift. And I could potentially see Enemy continuing, but I would expect support for at least at some point. Support for HTML5 and other non-native things in Enemy may be going away, or at least kind of staying still. So if you have an existing project, it'll still work as is, but I wouldn't expect to see continued HTML5 improvements and otherwise in Enemy.
Okay. And what about the Enemy roadmap?
Like I said, Enemy is a native backend for projects. So as needed, we're going to continue to improve Enemy as that back end. There also might be some changes where if you really did want to use only Enemy, that Enemy would be booting off of the OpenFL tools. But I would say in general, if you're a developer and you're creating something against the Enemy API, OpenFL is kind of the evolution of kind of the environment that we all know and love. So thank you very much for having me.
One more question.
Okay.
The last one.
Again, sorry. I believe mainly because of historical reasons, the Flash packages now, all the Flash packages are part of the standard library now. Wouldn't it make more sense now to move those packages from the standard library to the OpenFL library?
So I personally believe that being able to install Hax without any additional dependencies and be able to target any of the supporting platforms is great. Specifically for the uses of OpenFL, there is duplication where you're able to use OpenFL and we have our own copies of the external classes and otherwise, so that we can make documentation changes or other adjustments as needed. So that's kind of the direction things have been going, and we'll see how things go in the future. But
I'm very excited about this new direction, and I hope that we can continue to build the tools that you need to take your ideas, take it out of your head, and to get it on screens, get it on devices, get it out to people. And so this is a perfecting of the technology we've been developing these years, when we can lock down on the Flash API and we can have something stable and great, something you can rely upon, something that you can use to target the platforms that are available now, targets that may be coming in the future. And we can continue to innovate on what the next 5 to 10 years should look like for APIs. Thank you very much.
I'm feeling groovy.